All right, hello everybody. My name is Adam Braden, and I'll be your moderator for today's expert Q&A talk as we'll delve into the details and questions you have about C#, C++, and Rust and our WinRT projections. With me, I've got a number of our guests. We have Scott Jones, Kenny Kerr, Ben Kuhn, and Ryan Levick. Who are experts in this area, and also helping me out, we have Mike Batista. I'll go ahead and give each of those each of them an opportunity to explain a little bit about themselves and what they're working on. And after that, we'll start with the questions. So we don't have any prepared content here. This is really to support you guys and any questions you have about WinRT and our projection technology. So go ahead and start entering questions during this conversation in the event, and we'll go ahead and start responding to those. But first off, I thought I'd preview and give Ben Kuhn a chance to introduce himself. 1 second.
Hi, I'm Ben. I'm the dev lead with the Windows Runtime type system team, and work with a lot of the other folks here. Just looking forward to seeing what questions you have and how we can help.
Okay, thanks. Great, Ben. Next up, we'll have Scott Jones.
Hello, everyone. My name is Scott. I've worked on WinRT and Xlang technologies for the last several years with Ben and some of the other folks that we'll be meeting today. The most recent project I've been working on, heads down for the last 6 months or so, has been C# WinRT. That's a critical component of the .NET 5 effort, if you've seen some of the sessions on that. And that is an attempt to lift out WinRT awareness in the runtime and the C# compiler, and to put it into a library which is open source and independently maintained, and will provide much of the same gains and benefits as the C++ WinRT projection has provided over the last few years.
All right, thank you, Scott. Next, we'll hand it off over to Kenny to give a quick intro. Kenny's video, sometimes his camera's having a little trouble, so we'll keep him going as best we can.
Hi guys, my name is Kenny Kerr. I came to Microsoft, I think about 4 years ago, to work on C++ WinRT. I've now spent the last 6 months or so working on Rust WinRT with Ryan. Had a lot of fun. This Rust community is a lot of fun to work with, and it's been a great project to see how we can do much of the same things we did with C++ WinRT for Rust. Being another systems programming language, it's very interesting to me. Looking forward to hearing what you think.
All right, thank you, Kenny. Next off, we'll send it over to Ryan, who joins us from Germany.
Hi, everybody. I'm excited to be here. I'm Ryan Levick, and yeah, I'm coming here from Berlin, Germany. I am a cloud developer advocate who specializes on Rust. So I'm excited for all of your Rust-related questions. I am new to Windows programming, really in general, but also to WinRT, and so it's been a lot of fun working with Kenny over the past couple of months, and I've been learning a lot and excited to be joining everybody here today to talk about WinRT and all the great fun we have.
Okay, thank you, Ryan. And last off, we have Mike Batista, who works on the SDK and will be helping us with the some of the navigation of this event.
Yeah, thanks. Adam said it. I own the Windows SDK. I work with the rest of the people on this call, and I'll be helping moderate today's session.
All right, thank you. Let's see here. First off, we have a whole bunch of great questions. Looks like from Shane. Shane asks a couple of questions about Rust specifically, and how it compares to C# and C++. Kenny, I thought I'd bring you up to give us a primer on that.
Sure. I mean, these are very different languages. I would say Rust and C++ are similar in the sense that they're both systems programming languages. They're both deterministic. They both have, for example, deterministic finalization. There's no garbage collection. A fairly small runtime. C# obviously has garbage collected, managed runtime. So in that sense, C# is the outlier in that group. It's very different to Rust, and C++ serves a different market, I would say. But just in terms of the average OS developer, the average developer looking for a high performance programming model, Rust and C++ give you comparable features. Rust is more focused on safety, certainly is code security in the sense that you can more easily write verifiable code. And Ryan can speak more to this than I can really, but that's the way I would look at it. If you're looking for systems programming languages, you'd pick C++ over Rust. If you're looking for something more dynamic, but more tuned for memory models that are a bit more wild and interesting, you'd go for C#, and it gives you some flexibility there, but there's certainly trade-offs in both sides.
Thank you for that, Ryan. Do you have anything you want to add?
Really, I just want to add on to what Kenny said about Rust being kind of focused on safety. That's why we at Microsoft are interested in taking a look at Rust overall, is really for its safety properties. I'll be giving a session tomorrow about our safe systems programming languages effort, where we're looking at adopting more Rust in Microsoft. Because by default, Rust is a completely memory safe language. And so while obviously when you're writing C++, you don't want to have things like use after free and double free and all these kind of memory related issues that you try to avoid in C++. In Rust, by default, they are impossible to introduce. And so what we're hoping for with the Rust WinRT projection is to take that. So not only is the projection itself kind of bug-free, as you would expect in C++ as well, but all of your code around it should avoid these issues as well, and it should be impossible to introduce them.
All right, thank you, Ryan. One additional comment that I see that we're having some challenges with our publishing of the questions issue. Let's see here, was that do you expect Rust to become as well known as C#?
I can take that. As well known as C# is an interesting way to phrase it. I can imagine it being as well known in the sense of being as pure name recognition someday. That's certainly potential. I don't necessarily imagine it ever becoming as widely used as C#. That's because Rust really excels in the lower level systems programming space. And while I think it's definitely a very usable language when it comes to higher level needs like web servers, CLIs, things like that, you definitely give up a little bit of flexibility when you don't have a garbage collector. And so I can definitely imagine C# still remaining kind of a language of choice for a lot of use cases, and only when you kind of need the raw power do you drop down to Rust. But that being said, I hope that everybody can feel comfortable using Rust in their arsenal, so that when they do feel that need, there's no hesitation of jumping in and programming Rust when it makes sense to, and then jumping back out to C# when you don't need the kind of power and control that you get from a systems language.
Great, thanks, Ryan. Kenny, here's another similar question about Microsoft's contribution to Rust and what we're doing to make it more suitable for Windows.
Yeah, so the goal of the Rust WinRT effort is to really bridge that gap between the Rust language and the Windows operating system. Much like C++ WinRT makes it far easier for C++ developers to call and make use of Windows APIs, Rust WinRT is about making those same Windows APIs available to Rust developers. So the goals are largely the same. We want to make first-class support for Rust in the Windows Runtime through the Rust WinRT language projection or project. We want to make it possible for you to build WinRT components in Rust. So all of the same capabilities and features that we have in C++. So within the Windows operating system today, we use C++ WinRT very heavily for writing components. Obviously, we'd like to do the same for Rust, whether it's within the operating system or outside of Microsoft or outside of the OS group itself, as well as for simply making use of those APIs. So you can freely mix C++ and Rust code just across binary boundaries, if that makes sense.
Okay, we've had a few questions about Rust. I wanted to give Scott a chance to chime in here. We've got a few questions about C# and C# WinRT. Specifically, Oren asks, what is the difference between C# that was used in UWP and C# WinRT?
Well, the biggest difference is that the implementation of the support for marshalling calls from C# to C++ and back is no longer resident in the runtime or the C# compiler. Instead, it's a standalone tool. And so just a brief sketch of how C# WinRT works. It's a command line utility, much like CPP WinRT, if you're familiar, which consumes WinMD metadata files and produces C# source code. The C# source code is then compiled into an interop assembly. And the goal is that we would distribute these in place of primary interop assemblies for major components and frameworks. So the Windows SDK would have an interop assembly, WinUI framework would have one, standalone components like Win2D and so on. One of the challenges in doing it this way is that we do not have the inside advantages that the runtime had for optimizing these marshalling calls. But there are some features that are coming along in Net 5 and C# 9 that are going to enable optimal dispatch of virtual functions in both directions. And this is the heart of the WinRT API design, is that you're dealing with virtual method calls. So once we're able to implement these virtual dispatch calls without the overhead of creating delegates, then the performance should be very nearly what we have today. So that gives you an idea of sort of where C# WinRT is going as it compares to the UWP support that we've had historically.
Great, thanks, Scott. There was kind of a question here about interaction between Rust and C#. Let's see here. Oh, Ben, did you want to comment on that?
I just wanted to add a comment for folks that are asking questions. We have Adam and Mike moderating our questions and posting them. We're also running on a little bit of a video delay, and we're reposting the questions as we can answer them and speak to them. So if you have asked a question, please be patient and give us time, and we will get to it in turn. Please don't repost the question multiple times. They are in our queue and we're receiving them.
Thank you, Ben. I have a question here about, are there any plans to develop or support Rust inside of Visual Studio? Kenny or Ryan, which one of you guys want to take that?
I can respond. The Visual Studio team has not yet committed to supporting Rust officially. But if you look at Visual Studio Code, VS Code is what I use, what most of us use for doing Rust development. It has community-driven extensions that work fantastically well, and we've been using those without any real difficulty. There are also various debuggers that are available as extensions that work as well. You can use the C++. You can actually use the C++ extension, the official Microsoft C++ debugger and extension for debugging your Rust code, and it works really well because Rust uses the same fundamental compile, link, and debug binary formats that C++ uses. So the same debugging line stepping works just as well. So in terms of official support, I really can't speak for the Visual Studio team. They haven't announced anything that I'm aware of. But again, you can use VS Code today and it works really well.
Ryan, is there anything you'd like to add?
No, I think that's great. Other than VS Code is kind of the platform of choice for Rust developers already, and so if you haven't given Rust a shot on VS Code, I would definitely encourage you to do so. It's a lot of fun.
Okay, I guess similar to this Rust angle or Rust line of questions, is there anything? What is the development inside of Windows in terms of Rust usage, or inside of Microsoft in general?
Yeah, so Rust is definitely gaining steam internally. I don't think we're ready to kind of name specific projects where Rust is being used, but there are plenty of prototypes happening with components being rewritten in Rust, generally from C++, to see what the impact is on safety, on performance, and developer productivity as well. We're definitely happy to announce that so far things look really good. What we're hoping for is to continue those experiments and widen them out in the future, and also to work with the Rust community to make sure that we can help the community, and the community also can make sure that Rust is capable of performing the needs of a large enterprise like Microsoft is. And those experiments are going well. We have a few teams that have publicly announced that they're using Rust, such as Azure IoT uses Rust extensively, and you can find a lot of that code on GitHub that you can browse through. And in the future, we're going to be having more blog posts about internal usage of Rust and some of the benefits that we've seen from its adoption.
Great. Let's see here. I've got another question about, is the WinRT projection technology Windows only, or can it be used on other platforms? Ben, do you want to take that one?
Yeah, I can speak to that. We've definitely taken an interest in bringing the WinRT concepts to other platforms, and we started an open source project under the Xlang repo to do that. At this point, because a lot of the value in WinRT is in the libraries themselves and the APIs, and those APIs are still very Windows specific, we've not pushed hard on that. I would say the best I can say for that right now is stay tuned and give us feedback.
Okay. And similar to that question, does Rust or does the WinRT technology, is it supported on legacy OSs?
WinRT goes back to the Windows 8 OS. There's no plans to carry the technology back any further than that.
All right, thank you. Along the lines here of WinRT, what other language projections are being planned?
We're always interested in seeing what the community comes up with, and we're always evaluating what languages are popular. This isn't a place where I would make any announcements, but I'd say we have a keen interest in JavaScript and feedback about where people might have an interest in using WinRT on top of JavaScript. As some of you may be aware, the WinRT support that we've had in the past for web applications is in Windows, is built on top of the older IE engine and the Chakra JavaScript engine. And with Edge having moved to the Chrome-based or the Chromium codebase, there's no equivalent support in that codebase for WinRT. And so we're evaluating whether to reinvest in that area. Obviously, we have new support for .NET 5 and the C# work that Scott Jones has done. We have Rust coming up as a language that we're fully supporting. But we evaluate each case carefully. A full language projection takes really multiple years and a continued development effort to fully mature and to build it out as a robust production quality solution. So we try to not take on a large set of languages too quickly or make a choice too lightly about what languages might be interesting to support.
All right, thank you, Ben. Has there been any work done to, there's a question from Greg on, has there been any work done to interop Rust and C#.NET? Specifically, can Rust call into .NET libraries? Kenny or Ryan?
Sure. There isn't any specific technology or work done in that regard. However, our general philosophy is to use the Windows Runtime or WinRT to do the language interop. So in theory, once both C# and Rust WinRT are on par with, for example, existing C# and existing C++ WinRT in terms of the two sides of the divide, we should be able to do that kind of interop very naturally. I've always found that using WinRT for C++ and C# interop is the most natural way to do that. It's very convenient, and I would expect the same for Rust and C# as well.
Okay. Pete Major has a question about C++ WinRT is improving quickly. One area he'd like to see improvement is desktop C# plus a custom C++ WinRT components, where project references are not always allowed. And desktop apps need manifest to avoid registration issues when not packaged. Kenny or Scott, would either of you want to comment on that one? Scott?
Sure. Yeah, I can take that. Yeah, we recognize that there are a number of interop scenarios that are challenging today. There's UWP to unpackaged. There's managed to native. The Visual Studio team has been working to break down those barriers, so it's easier now to have a project take a reference, an unpackaged application take a reference to a UWP assembly. And as well, they're working on, Visual Studio team is working on making it easier for activation scenarios. So for a native application to activate a managed component, those are still on the drawing board for the most part right now, but it's recognized that these interop scenarios are more and more important. There are a couple of libraries available today that help to bridge the gap. There's the VCRT forwarding library, which is on GitHub. There's also a reg-free WinRT activation feature that was introduced about a year ago with 19H1. And that feature enables, with some manifest work, an application to activate a WinRT component outside of a packaged context. Historically, that was only permitted for UWP packaged apps. So, and there's some other tooling that we're working on to enable that sort of reg-free activation to go past 19H1, further down level, using detours. So we recognize the need to improve the interop story, both at runtime and at design time in Visual Studio in the IDE. And we're working with Visual Studio team to improve that and remove those barriers.
Thank you, Scott. I found there's a few other questions here about WinRT features, calls, conventions that were particularly difficult to represent in each of the languages. Scott, Kenny, is there anything that stands out in your mind as to which were some of the more challenges for C# or C++ or Rust?
Well, certainly features like async, ultimately WinRT is always just concerned with interfaces. And so language features like async can ultimately be boiled down to an interface. Delegates and events are interfaces at root. But the way that they manifest in different languages can make it a challenge to project those in a natural and familiar way. I know that Kenny spent a lot of time to make async work in a natural way in C++ using coroutines. And we had to do a bit of work in C# as well to project to tasks in a natural way in C#.
Anything you want to add, Kenny?
Not really. That does a good job of summarizing that. I mean, every language has some unique challenges, and there are always going to be some trade-offs, some delta where a WinRT concept doesn't map perfectly to the language that you're targeting. But that's why we need to be creative and find the most natural fit, and hopefully and usually I think we get that right. And it works pretty well. So I'm satisfied. I mean, WinRT doesn't have the richest type system, but it does a very good job of providing the basic fundamentals that most languages can be mapped to, and I think it does a pretty good job.
Okay, I think we've got a new question here as well about roadmaps, specifically the roadmap for WinRT regarding Rust and C++. There's a question, is Rust really preferable to C++ nowadays? Do you replace components written in C++ or Rust, or are there components that should stay in C++ forever?
I think that's more of a choice for a specific project. You know, if you have a large C++ code base, it may not make sense to rewrite a lot of code in Rust just to say that you're using Rust. But you know, if there are clear benefits to using Rust over C++, and maybe those benefits matter to you, and then that's certainly a choice you need to make. But you know, as an example, in the Windows operating system is a monstrously large C++ code base. And yet we're very serious about looking into using Rust within the Windows operating system. So it's not really a choice of, well, do I use C++ or Rust? It's often a choice of, well, you can start to use Rust in certain places. As Ryan mentioned, you know, it may be just looking into experimenting and finding out what works and how does it scale. It may also be identifying areas that are historical weaknesses in the project and saying, well, this area is an area that often causes trouble for us. We may want to focus on rewriting that portion of it in Rust, perhaps a parser or something very sensitive. The key, though, is making it possible for developers to bridge that gap naturally and not have to go full hog and, you know, rewrite everything from scratch on the get-go. And that's where technologies like the Windows Runtime make that possible, because you can begin to turn over certain components and certain features in Rust without having to affect the rest of your code base, because it can continue to simply treat them as WinRT types that you can consume and call as you have done before, regardless of whether the implementation may have changed from C++ to Rust.
Okay, thank you, Kenny. One question that comes out around Project Reunion. In general, Project Reunion will probably be better answered in the Windows App Developer Meet the Team session later tonight from a Seattle perspective. But there is a question around, how does Project Reunion change the trajectory around WinRT, Rust, C++, etc.? It comes from Peter. Ben or Kenny? Yeah, I'll send Ben. Let's have you take a look at that one.
Sure. So I think the right way to think about these are a better together story, maybe. The WinRT API system is the way we write APIs for Windows now. We basically have three forms of APIs for Windows, the way we kind of mentally categorize it. There's Win32 APIs, which is the classic, include Windows.h. There's COM style APIs, all of your IUnknown based APIs, and there's Windows Runtime APIs. And they're just Windows APIs. Other components can also expose APIs in any of these styles. You can write a component that's exposed via COM APIs and callable by other code. You can write a component based on WinRT APIs and it's callable by other code. Project Reunion will include a lot of APIs that are WinRT based. There may also be some APIs in Project Reunion that are not WinRT based. They may be COM or Win32 based on the needs of how that component interacts with other parts of the system. But in general, I think you'll see most of Project Reunion being WinRT style APIs.
Okay, thank you, Ben. Well, we're almost out of time here. I think let's see here. Lots of great questions. I'll go ahead and post a bunch of links to C++, our WinRT projects. It'd be great to ask for you guys to follow up with additional questions and issues in our repos. One last question here. I guess from Anonymous, we have, when are we going to get a new Windows SDK release, and will it include Rust bindings?
Oh, I can take that.
You can jump that. Okay.
So all of our WinRT tooling is now being developed open source on GitHub, and it's being published via NuGet packages and Visual Studio extensions. And so Although I can't give you a date for an update for when the next Windows SDK will come out, the tooling that's available can be used with the existing SDKs and metadata to produce bindings. So for instance, you can use the latest C++ WinRT with a Windows SDK that may be 2 years old and get the latest benefits of the latest projection of the current C++ WinRT behavior. The same will be true of Rust. So once we've published released Rust tooling, you'll be able to use the metadata in whatever SDK is in market at that time and use Rust bindings against Windows. That's one of the wonderful things about having this tooling built in the open and shipping on a different cadence. We can react to the community on a cadence that makes sense for the developer tools and the developer ecosystem instead of basing it on the Windows product time cycle, which is driven by different market factors.
All right, thank you, Ben. Folks, I think we're at the end of our session time. We definitely appreciate all the questions that you've answered. In the chat, I did publish links to all of our repos. It'd be a great place for you to engage on further questions, specifically about the WinRT technology. And if you have any further questions, please let us know. You can find many of us on Twitter as well. I want to thank you all. I want to thank our speakers, Kenny, Scott, Ben, Ryan, and Mike for helping us out here. And looking forward to seeing all the work you guys will do supporting building Windows apps. Thank you very much, and goodbye.